All righty. We are probably streaming.
Hopefully so. I want to make sure see if it
There.
loads.
Got you.
Good. All right, we'll go with that. All right, so thank you everybody for coming out to Splunk WashDC. Thank you for Crypsis for hosting us. Tonight we're going to have Doug Toppin talking about integrating Docker logs with Splunk. A couple items of business. So for next month, we will probably be meeting in the Splunk space in Tyson's Corner. That's not official yet, but it's still in the works. But that's kind of what we're shooting for. It sounds like that might be the permanent, hopefully be the permanent location.
Yeah, we're hoping to get that all settled over the next couple of weeks, but that's the plan, at least through the rest of the year, to do it at Splunk's office in Texas.
Cool. Other things out there, so .conf is coming up. The call for papers for .conf is already passed, so you can't really submit proposals for new talks, but definitely hope everyone can make it out, participate, represent Splunk WashDC, Splunk Northern Virginia, whatever you want to call it. Hopefully we'll have a table or something out there so that everybody knows how awesome we are. Hopefully no one, I don't think, has heard about if their talks have got accepted or not, but hopefully we have some people representing the area. Splunk has also just announced a new competition. So in Splunk 6.6, there's a new feature called Trellis Layout. It's a quick way to do a bunch of new cool visualization stuff with base searches. They're actually doing kind of an open community competition to see if you can come up with the coolest visualization example with the Trellis layout. So we'll share the link in the Slack channel, or we'll pass around some other way. But if people want to get together and like work on an idea to submit for that, because it's all kind of done by the community, we'd be happy to facilitate that. So if they're just involved meeting at a coffee shop or a brewery or something and working on it, we'll figure out how to do it. But if you want to do it, just start the communication going. Trying to think anything else.
Talking for a little while I check audio.
Okay. So I'll go ahead and pass it on to Matt. I'll let Matt from Crypsis give a little brief intro.
Just to keep this quick, thanks everyone for coming out. The Crypsis group, we're a Splunk PS partner, primarily on the security side. We also do other security type consulting work, and most of our work is forensics type work. But yeah, if you have an issue, give us a call, I guess. If not, thanks for coming out. We like supporting the community.
Well, real big props to Crypsis. They really got this all started off. Rinaldi, Matt, and Sandy were all part of Crypsis to begin with. And Crypsis is still strong in the group, so we appreciate everything they do. Before we get started, the last thing just to mention is if anyone wants to do a talk, if anyone wants to do a presentation within the group, just reach out, talk to us here at the meeting, talk to Matt, talk to myself.
Wi-Fi. There's Wi-Fi called syslog.
What he said.
Go for it.
So open Wi-Fi if you get it. But yeah, other than that, if you have an idea for a talk you want to do, just come talk to Rinaldi, myself, Matt, Sandy, anyone, and we'll see about getting you on the schedule or talking about ideas, whatever.
Who here submitted a call for paper? Hands.
All right.
All right. So there's a number of presentations right there that we can use. You know, even if you don't accept the comp, we'd love to hear the content. So
absolutely. If you get accepted for comp, we will probably open the floor to you doing practice runs within the group like we did before. So I guess with that, Doug, are you ready?
As far as I know.
All right, I will surrender the floor to Doug.
All right, let's try this. Let's see what happens. This should be now what is showing on the screen. Oh, go ahead.
We got a fan going over here. We can just make sure it's really loud.
Oh, I'll talk. I can talk loud, believe me. All right, let's see what happens if I do this. So if somebody goes to the YouTube channel now, what you should see is this. So if somebody wants to do that, please go ahead and let me know. Actually, I can do it myself.
Is that the Slack channel?
I did not put it. I did. I might put it only in Meetup. Actually, let me confirm it. I've learned the value of doing an audio check. Let's see if. Good golly. Stranger things have happened than this one, as far as I can tell. I'm not wearing earrings. I'm wearing earbuds. So there. All right. So I'm Doug Toppin. I'm going to talk a little bit about Docker and Splunk. And then along with me is Eric Noriega, another guy I work with. He and I are Docker trainers, actually. We teach classes at this at our company, and I should say for our company. And it's a fascinating subject. Docker is one of those things, and Splunk and log aggregation in general kind of come along right behind that. So what I mean by that is tonight what we're going to talk about are a few things. I'm not going to go a whole lot into Docker itself, meaning how containers work and that kind of stuff, because there's no lack of people out there that are much better than I am at going through that. And in fact, if you take our class, you'll see it. We do 2 days of intro to Docker and 2 days of advanced Docker. And by the end of that, you're Dockered out, basically. You're ready for your containers to go away. So I'm not going to talk about the details of Docker itself. Instead, some of what we're going to talk about are what does it take in this Dockerized world or containerized world to get that log data and do something with it, because there is a boatload of log data. I mean, at the end of the day, you got more logs than you know what to do with it, because they're all over the place. And I'm going to go over some of the details of that as to things that you have to consider if you're looking at going into a container environment. What you're going to have to do to integrate that with log aggregation system. And for some of what I did for this, I did it with Splunk server running in AWS. But the focus isn't really Splunk itself, because I'm positive all of you all are better at Splunk than I am. I'm kind of like, I got a foot in both boats, and I have not gone into the water yet. So that's the sort of things I wanted to talk about tonight, are the things that I've learned from a Docker perspective, of things that are useful to capture, collect, et cetera, and then ways to get them into the outside world, that being Splunk in this case. So we're going to talk about what are containers and what challenges they present. There are no lack of challenges. You've got a big old list of challenges to deal with, deciding on how far you go into this integration and the kind of stuff that you're going to get. What are log aggregation systems? You probably already know all those things, but I've got a few slides on it because they're worthwhile to sort of review that perspective of what does it take, what is a log aggregation system? Because once you go from one instance of something and looking at the syslog to a bazillion containers and a bazillion nodes and instances and so on, and those all going somewhere, hopefully into one place, that log aggregation or aggravation system, as I frequently say, becomes pretty important. Some of the approaches for managing that volume of log data that happen, and there's not a small thing, and you got to think about it from the start. Some various container environments. There are a few of them that are out there, different things associated with that. I'm going to talk a little bit about that. Some potential architectures to consider on what you're going to do for a Docker environment, and then log aggregation comes along with that. And some lessons learned that we've experienced, or customers or whomever that we've talked to have experienced in these areas. So these are the kind of things that we're going to talk about tonight. Again, you all are almost certainly more pros at Splunk than I am. I might know a little bit more about Docker, but I might not, because I might just be doing interpretive dance. So we will see. So containers have been around for a long time. If you look at Linux C groups, sort of where everything got started, you got this nice little truded type thing where I'm going to run this application inside here, and I'm not going to let it do nothing but what I want it to do. Containers are sort of the genesis of containers, kind of came from that. And they got really popular. Now, the term Docker popped up a few years ago. Let's say the Docker company, for example, has been in existence a little over 4 years. It's hard to believe that Docker, that something could evolve so much and be so broadly accepted and found uses for in that period of time. It is astounding that a 4-year period of time can do that much. But when I say Docker, it's important to recognize there are various kinds of Docker. There's Docker with a big D, that's a company called Docker. There's Docker with a little d, which is I type Docker to do something. And then there are containers, which is something else. So they're not something else, but another subset of that area. So there's a variety of aspects. When you say Docker, what I'm referring to is Docker with a little d in pretty much everything we're doing tonight, except the fact that I'm using something called UCP, which is a open source thing, or a thing basically for clustering, which uses Swarm, which is a way to distribute containers and workloads, et cetera. But those kind of things don't necessarily matter from those specific perspectives as much as some of the concepts that I'll talk about, and show you some places that it's important to be aware of when you're talking about these sorts of things. So again, there's different vendors for it. When you say Docker, you can be talking about, well, I'll actually cover a few of them a little bit, but you'll be talking about the Docker company, their products. You could be talking about ECS, could be talking about Red Hat and OpenShift, could be talking about Kubernetes and Google Cloud, and just on and on, or something that you're rolling on your own. Or for that matter, you could be talking about the Adobe project. You could be doing all sorts of stuff with containers So Docker is not one thing. It is an ecosystem, for lack of better terms, or a large, broad area that has a whole bunch of stuff inside of it. A lot of this came around because of microservices. Everybody wants to run little things now. Rather than one big old monolithic war file with a boatload of services inside of it, that then means when you make a change, you've got to deploy that war file. You've got to do all sorts of jar work and all them other things. It's sort of evolved to, I got a little piece of code that has one little endpoint and it does one thing, and it's very little bit that does something, and a couple with something else, something else, something else. And then you end up with this microservices environment, which I think can easily turn into, you know, spaghetti code, spaghetti services in a sense. We've got all sorts of connections all over the place. Containers and Docker really facilitate that. You can run a ton of little endpoints all over the place and then wonder where everything is, what it's doing, and all that. That's where log aggregation gets kind of important, because when you got one developer sitting on his machine and he's running stuff, he knows exactly what's going on. He knows where it's going on. Moving to that clustered environment, which is something else we'll talk about a little bit, all of a sudden that something is spread out everywhere, and it might even be moving around. I mean, it's entirely possible that these containers are happening here and there and everywhere. Meanwhile, you got operations sitting there wondering, what's going on? I don't know. And customer calls and says, hey, do you know your service is down? That's usually the worst phone call you can get, frankly. So that's why I think some of these things are important. Log aggregation is just as important as containers, because you have to deal with it in a broad scale. Clusters are a result, are part of that, meaning clusters of nodes that are genericized, have a generic capability called Docker or containers on them, where you can take this service and run it here, run it there, and run it there, and over here. I need to have an Ubuntu-looking environment with an Ubuntu file system. Over here I need CentOS, over here I need RHEL, over here I need something else, Alpine, etc. All those things are happening all over the place. In the past, you had to deal with different machines for each of those things, which is a pain in the butt. You had to have one operating system here. You had to have another operating system, different version, same operating system here. You had nodes everywhere. With Docker, that becomes easier because now you have something that can run different types of things on it, whereas in the past, you had to have at least one of each of those types, which is particularly true in a build environment. When you're looking at Jenkins or et cetera, those kind of things, instead of having a build farm of different machine types, have them all have Docker and be able to distribute or run the workload that you want that on the thing. VMs were how that were done in the past. Now, I'm not going to go a whole lot into detail on Docker tonight, because there are other things I think that are more important. But VMs were big old things like this that had a whole stack of stuff in it. Docker containers, right now I use the terms interchangeably, which is not right, but it's the way that I do it. Containers are going to have much smaller footprints, less overhead. They're going to start faster. They're not going to be as big. Going to be able to pack different sizes in different areas, different nodes, etc., rather than simply saying I want 5 VMs on this machine and 5 on this, etc. Instead, you've got Docker engine that's saying container, and distributing all over the place. And then you've got some sort of orchestration behind it. Then you've got some sort of networking behind it. And again, I'll talk a little more about that in a bit. Distributed applications result from that thing. So there's some neat stuff that you can do out there with containers. Docker Compose is sort of an example of that, where you could have a single YAML file that describes multiple services or multiple things inside of it, and you can simply tell Docker, hey, go start this up. And it'll go out there and run all those things, connect them together securely, distribute them out there in a swarm somewhere. So it works pretty slick, but it also means now you've got a lot of abstraction between you and where something is actually running. Ideally, you don't care where it's running until you're troubleshooting, and you say, what node is this service, this container in this service running on, and what does the syslog inside of it look like? Let me SSH onto that tail var log syslog or whatever it is you got to do, or Docker logs, etc., and get really confused. Or you go to the log aggregation system and say, show me everything that has to do with this service, for example. So it's an example of some of the things that make these pretty interesting. In the end, many more monitoring points. There are many more places where there are choke points or useful things to get information from. Now, you can get that information by SSHing yourself and going right to them and looking at it the hard way. But if you got a 10-node cluster, that's one thing. Then figuring out which node it is, how to SSH to it. If you got a 50-node, if you got a 1,000-node cluster, you're probably not going to do that. So again, that's why aggregation, which I prefer to say, I think matters so much. So the challenges that containers present start with more than one of something, almost invariably. How many nodes have you got in your environment? How many containers are running on those? So you might have just one node, but you might have 50 containers running on side the thing. And some number of those containers may be overhead associated with something else, not just application containers. And that's something else that I'll talk about when I talk about UCP in this case, is that Docker engine may be doing something other than just running your application containers. It may be running something associated with the orchestration environment or whatever. The engine behind it may be in a swarm mode. It may be doing other things. It may be managing secrets, a variety of those things. So again, I'm not spending a lot of time talking about Docker as much as just to recognize the variability and scale of things that could be going on and going on dynamically, because you might be used to a traditional environment where you run a war and it puts up service, and that service is sitting there for eternity until you bounce it. Or you could run dynamically containers that put that endpoint up, do what you want, and they go away. So they may come and go at a high rate of speed. They may travel around through your farm. Clusters may go up and down, nodes may go up and down, etc. That's that aspect of they might be ephemeral, they might not be. They may literally be flapping all over the place depending on demand or need at any moment in time. Because now you're talking about the cloud. You are probably not running a farm of 1,000 machines yourself, and your operations group have managed all of your racks all over the place, etc. Wouldn't be unusual to find yourself in the cloud. Now you've got this situation of elasticity that also contributes to coming and going, because you don't just have scaling of nodes because you need 5 of them. During your peak, you might need 50. During your valley, you might need 2. If you're not scaling, taking advantage of that elasticity in whatever environment you're in, you're paying to keep the lights on whether anybody's in the room or not. And that's one of the by far and away, the most important things about the cloud environment is take advantage of elasticity. Don't run stuff that isn't being used. Pack your stuff into as little hardware as you possibly can. Pay for that hardware and terminate all the other stuff, which now you've got scaling. So scaling isn't just associated with we're going to run 5 more. Instead, it's entirely possible your auto scaling group is saying we need 20 more. Now we don't need 3. We don't need 20. We're down to 1 or whatever. So that complicates this area as well. And this is an area of complexity that container environments are challenged somewhat by, to some degree. That scaling of nodes, doing it by hand, is one thing. Saying, run me another node, run me another node, run me another node. Now you got an ops guy sitting there doing that. Or you've got auto scaling groups doing it for you, but that node's got to come up, it's got to join the cluster, it's got to stabilize, you got to get whatever metadata transferred to it, and then it's ready for workload. That is something that you may find in whatever cluster environment you are in or moving to. It may not handle as well, and you have to plan for it. That planning is having a person person scale or not scale, or else it does it by itself, but it does it by itself. It's got to work its way into the cluster. That can be a little bit more of a challenge depending on what's going on. So, one of the things, this thing's coming and going. So if something comes into the environment, does that mean that it needs to register with the log aggregation system? Meaning, if your log aggregator is sitting there waiting for something and somebody says, squirt, here's a message, and that message has in it the IP address it came from and then the content itself, is that good enough? Or is it useful to have that aggregation system a little more aware of what this node is, what type of node this is? Is this a manager node? Is this a worker node? Is this something else for that matter entirely? And if so, when that node comes up, does it have to tell tell Splunk, for example, say, here's who my source type is? Other than just a host name, is it something a little easier than that that it needs to do? So consider those type of things, where when something is coming and going, particularly at the node level, are you going to register it with your Splunk service or your aggregation system, or is this IP address as at least the root of where this is coming from good enough? Now, small applications all over the place. As I said, take this big old war file in the past that had, I'll pick on a few service works. Had a war file that has in it 25 different services that all came up in one JBoss. They're sitting there, that REST endpoint sitting there. It's all in one place. You know exactly where that thing's coming from. put that into a container environment, run each one of those as containers and scale them individually, and they're just going on all over the place. That goes into that next area where when that log message goes from the host to an aggregation system, it's got who it's coming from, but is that good enough, or is there enough inside that message or is there not enough inside that message to even more specifically identify? Or is it just going to say, this is coming from container ID 1234? How's that going to make sense to an ops person down the line or a dashboard down the line? So that's some of the other challenges, and I'll show some examples of that in a bit. So services all over the place. That's a good way to think of it. They are literally all over the place. As a result, how are you going to trace requests from one to the other? For example, in that big old war file with that big old application, when a REST request came in, you assign a unique ID to it. That gets passed down to all the subsequent services in the chain. That the request ID gets logged on every subsequent one. That works perfectly for tracing the progression of a single request. Now, imagine that in a cluster environment where the services literally are all over the place, not in the same JVM. Are you going to pass that request ID around as metadata inside in the header of every request being passed on, for example? Because if you don't, how are you going to trace these requests from beginning to end when they're moving around through nodes, containers on various nodes, scaled individually, etc.? That's a challenge to consider from a development perspective. How you log and what you log will become important to you, because otherwise you're just going to get a boatload of messages in Splunk, and you're going to start trying to figure out, how do I associate these with each other, rather than just looking at one specific log message. You're frequently going to be interested in the complete chain of requests. Some of the other challenges: how these containers get run, who is running them? Is it Swarm? Is it Kubernetes? Is it, I mean, just a range of things. There are different ways of doing it. Is it ECS, which is a service sitting out there, but you don't necessarily know what's happening under those covers? So that's another aspect to consider as to what it is that is being logged and where it's being logged, who's logging it, and how much insight you have or care about. Now, because of that, I'll mention this in a bit. This stuff's existed for 4 years. I mean, obviously, containers have existed longer than that, C groups, etc. But think of the traditional Docker with a little d, for example. That's existed 4 years. It has evolved a fair amount in that period of time. You can assume it's going to evolve. So you're going to get turnover in the way things that are being done, and you have to plan for those in advance as to how orchestration is being done, and do you need to monitor it? For example, and I'll pick on Swarm and UCP in terms of, or Swarm specifically. If you're not monitoring the orchestration of what's going on and something funny starts going on, what are you going to do? Are you going to call up the vendor and say, hey, something funny's going on? Or are you going to have some insight into what those containers at the orchestration level, meaning the overhead containers, are actually doing based on what they're logging? And so your application logs are, a lot of what I'm talking about aren't really application logs. It's kind of that literally Docker with little d and container engine logs as to what it's telling you that might be useful to know. Now, it may be stuff you don't need to keep forever. You may think in terms of Splunk as to long-term storage and indexing, and then shorter term, where just the last X number of days are useful for you to detect something's going funny before it becomes an outage or see some sort of trend happening. So you end up having to plan on gradations of storage, I think, because it's useful to collect as much as you can that you can afford to. And afford always comes into the equation somewhere. I say that with great confidence. How much of this are you going to monitor? Docker engines. There's a lot of Docker engines sitting out there. Each one of your nodes got at least one running on them, and you could conceivably have a node that has multiple network interfaces with Docker engines on each one of those network interfaces, for example. So it becomes important to think about these monitoring points. I got some pictures later on just to show you the lines going all over the place, just to make you consider all the places that something useful might be found for troubleshooting down the line, particularly if you're having trouble in general with involving architecture that is just your infrastructure. One of the things, how does he know what he's getting? Send that message off to Splunk. Server Splunk says, I got this from IP 10.10.20.35. I wonder what that is. So are you going to associate names? Are you going to have something in the service message that tells it a little bit more about it to make it easier for you to query down the line, or even have canned dashboards that are monitoring some of these things? By the way, stop me anytime and ask questions, and I'll shrug with the best of them. So probably, but don't hesitate to ask questions. Now, containers are going to use a ton of sockets. You got sockets everywhere. You can picture sockets and then imagine more of them, and that's what you're looking at. When a container gets run, a surprising amount of work happens. It's very interesting to put the Docker engine into a debug level mode or verbose mode, where it's logging what it's actually doing. And I'll talk about that a little bit later. In fact, with Docker events, you can get some really good insight into what is physically happening. Because when a container runs, it isn't just run a program. It's set up networking, it's set up disk volumes, it's set up memory space, set up C group. A whole lot is happening just to run that one little thing that says hello world and then dies. It's surprising how much work is happening to do that. And you can see all of it if you put that engine into a debug level mode. It's useful to do that sometimes from a development perspective, just to get an understanding of what is actually happening when you do it. And Docker events is a really good way to learn what Docker actually is. Again, saying Docker generically. So here's the next one that's fun. The architectures. All these great new container architectures out there. You got this great new UI that is completely different than the UI you've been using in the past. Go to your operations group, and they're used to the Splunk UI, for example, for monitoring, or they're used to CloudWatch, or they're used to whatever. But in the container environment, you probably have a new one. You got ECS, you got Google Cloud. Their thing is completely different. All of these are different. Your ops group is looking forward to you putting up something new that they have to learn how to use, because that's what they like to do. Probably not. That's why integration into existing environments is really worthwhile to think of, and that's why that log aggregation system matters to me. That's something that matters to me quite a bit in terms of you can do all sorts of great new things with EFK, for example, otherwise, but it might not be what you're already using. What you're already using, if you can fit into that, your ops people are going to be happier, and that's what everybody's goal is, to be ops people. It's not to have multiple things if you can avoid it, and I think that log aggregation is a starting point for that, as to ways to make it easier to monitor and understand what's happening later down the line. I mentioned this earlier. How closely do you need to monitor whenever you roll a new version of something in, or a new version of an orchestration container rolls in? It wouldn't happen by itself, probably not. But got a lot happening under the covers nowadays in container environments that you don't necessarily have as much insight into, and logging will help with that. So you have to decide how much of that logging are you going to pick up. Here's a good one right here. This is something to look out for. What this says, and if you're not familiar with Docker, you can run a container. That container can be sitting there doing whatever it does. And then if somebody has the ability to, they can, in effect, run a shell in that container. They can jump inside that container and look around. CD, look around, see files, etc. So let's say you're running something and the container's having a problem. You got a developer that has access to production, because that's always a fun thing to manage. And he execs a shell into that container, looks around, sees what's problem, and fixes something in that container. Is that an auditable event? Is the fact that somebody execed a shell, ran a shell into that container auditable? I haven't mentioned auditable, but that is something else to consider from a log aggregation system. There's a lot happening that it's not a bad idea to have a little trail of breadcrumbs or an audit trail that says, here's who did what when. And even if they were allowed, it's still a good idea to have it so that somebody doesn't go make a change and break something. Or somebody that doesn't jump in and finds an environment variable that has a password inside of it, or an AWS secret key or something like that. So auditing is just as important, and log aggregation can facilitate that. I mean, there's other ways of doing those sorts of things, CloudTrail or examples of that, et cetera. But if you can actually tell that somebody execed a shell into a running container in a production environment, it's worthwhile asking why they did that. Because it's possible they did it just for fun. It's possible they did it for something other than fun.
So before you go to the next one,
Absolutely.
is that more equivalent to like a shell history file, or is that more equivalent to like a Linux audit D style output, where it has owners of processes and how long the process ran?
Okay, so I don't mean audit trail in the sense of literally a formal audit trail or Docker audit. There's no Docker audit. What I'm saying is keeping a record of the events that happened, that transpired, and treating that as an audit trail. So it's not like it's specifically audited. It's that you can tell somebody exec the shell into a container. That's an example of it. And that is what I would consider an auditable event. As to in a production environment, why do they do that?
But not necessarily what they did within that exec shell.
Correct. That's okay. They're right. The fact that they did anything, the fact that they had access to it, that's probably a better term for it. That they gained access to something, but you don't necessarily know what they did depending on what that was, because there is a shell history inside there. Hi, that's an interesting question. I will remember that.
So what I would say is that if you own a Linux box and you have audit running,
yep,
and you're willing to try to figure out what the container ID was that the process ran under, then you can use the same standard audit tools.
Okay.
Because what will happen is that container is a set of processes that are defined, and they will do the same things every other process on the system does. You'd have to map in that the shell opened up at some point within the process space, within the C group space, and then you could trace everything that exec from underneath that point, or the shell itself, depending on, you don't really need to exec anything technically, but you could trace it down through. But there's not a lot of tooling to do that. Specifically, processes, yes. Containers, yes. Linkage between the two. Now you're
Hard.
talking- yeah.
Sounds like it's hard to, if you wanted to get that level, it would be some effort.
Well, and you may not be, so you're execing in, the Docker daemon is giving you the access and spinning up that process. So who did it? Maybe a reasonable amount of effort to figure out.
Okay.
I just want to make sure nobody's complaining about the streaming or anything, right? I see a couple of messages, but it doesn't look like it. Okay, I just want to make sure that it's hard for me to tell if everything's working right or not when I'm standing up here.
It's coming out.
Yeah, okay. All right, so again, a whole lot of resources going on, a whole lot of behavior going on potentially at the same time. You can prevent things like this. You can get to serious granularity in container environments. It's something to be aware of, that you can really restrict via, not capabilities, or it is capabilities. Anyway, at the C group or kernel level, you can very tightly control what somebody can do so you can prevent this from happening. But just knowing that it was attempted is one thing. Knowing that it was successful is something else. It's not a bad thing, but you can, depending on your willingness to granularity, you can prevent all sorts of stuff all over the place. You may not do it out of the box. So, again, stuff's evolving, no question about it. It's hard to imagine what'll be different in 4 years. So I can't imagine the 3-year plan anymore, frankly, in terms of how you're going to do stuff. So plan on your environment changing, which means plan on that aggregation system right from the get-go, being able to facilitate different stuff running all over the place. Whole lot of things are going on. Whole ton of orchestration. I mean, Docker is fundamentally based on, go get me an image which is composed of a bunch of layers somewhere, pull them onto my machine, put them into a cache, and then instantiate them into a container, run that stuff, and then associate all the networking volume, disk volumes, et cetera, with it. A whole lot of activity that are happening. It's worthwhile to be aware of some of those things that are happening at the image repository level, meaning in the past, build me a binary, plug it down on this WAR file on this machine, I know where it is, versus Docker run or Docker pull that may go out somewhere else and get something, and then pull some of it or all of it down to your repository on your machine and run it. Was that what they were supposed to run? Is it the right version? Who did it? What's the last one that was out there? What versions are they allowed to run? All those things come into play when you're talking about a container environment, Docker specifically. So, some of the challenges. This picture is a simple picture. All it shows is you got a host sitting right here on it, you got a Docker engine, and you got a Docker CLI. And you might have an application container when somebody runs it. That's one thing. You got a developer sitting there, it's a Docker run. That's what they're doing. Except the other side of that is an image repository. When somebody says Docker run, what's really happening is it's doing a Docker pull. Which is really happening is it's going to see, does this image exist? Do they have access to it? It's got to go somewhere to find that image. It could be Docker Hub repository. It could be ECR. I mean, it could be a Elastic Container Repository or whatever AWS calls there. I can't think right now, but it stands for ECR, or ECR is what it's called. This is the other part, is where are your images and layers for those images kept? And is it under your control? Are you running the things you expect? What's inside of it? Can somebody pull on stuff? How's stuff being pushed to it? So this is the simplest case of what stuff looks like. Let's go a little step further. Okay, here's that one node guy, except now this is called manager node. This is called a worker node, cluster container. So got one manager, one worker, for example. You might have one manager, two workers. You could have X managers, X number of workers. You've got the CLI or UI sitting out here, which is somebody sitting there typing Docker. Because when somebody types the word Docker, what's actually happening is they're just opening up, they're just running a client that's using the API to talk to this guy, for example, the manager. And then the manager is who's doing a bunch of other work. So sometimes what you're going to find is it'll be a little confusing as when somebody types the word Docker, what's actually happening? What progression of events are occurring? Most of the time, all that they're really doing is using the Docker API without realizing it to talk to this guy, and he's doing a fair amount of work. It'd be a Docker engine for the manager in this case. He might be going out here to do stuff. He might be going to the cluster to do stuff. So those are sort of the pieces that are sitting out here, and then you got your sad little logging server out here waiting for something to do. And we're going to show more about that in a bit. So log aggregation, again, you're probably familiar with this more so than I am, but it's worthwhile to talk about some of these things to see my perspective on it, simplistic though that it may be. What are they? They are a place to send your log files, log data, useful things to keep a record of somewhere that lets somebody else go to them with an isolated UI and type query, search, whatever it is that they type for this specific log message, or this specific host, or this specific container, or this specific label on this container that got run somewhere in the past. So with Splunk, it's got a ton of stuff behind it, obviously, with analytics, et cetera, just a range of things that can happen that make it far out, basically. So what log aggregation systems are going to tend to care about the questions that they're going to ask are, where did this come from? Who sent it? Is the IP address, whatever it is. Next, physically where it came from on that thing, for example. I mean, was it Docker engine? What was it? Syslog? Was it what? What is this thing? Is it plain old text? Is it JSON? Is it JSON with some weird format inside of it? Do I got to decode that? Do I got to pull fields? I mean, all those things are happening at the aggregation system. What is it? Is it JSON? Is it just plain old text? And lastly, what is inside this thing? They're going to care about things like, is this one of these, or do I need to classify it and group it with everything else for this particular service, or whatever it is that you want? So how do you group these messages, or do you group them? How do you know they're grouped, and so on? Do I care about it? Do I need to do something with it? Do I need to save it? Do I need to send it to the indexer? Or is it in the indexer? Do I do something? Do I store it? Do I just drop it on the floor? Do I filter it out? How long am I going to keep it? Do I keep it for now, or do I keep it forever, or just for some period of time? Do I stick it out in S3 and whatever I want, or et cetera? So, and does anybody else care? Do I need to alert on this? Is there something in this message somebody needs to know? Rarely do alerts say everything is fine. Generally, that I don't think I've ever gotten an alert. Still get alerts from a customer that I worked with a couple of years ago for a couple of years. Their Splunk is still telling me about things I don't want to know. It's like, no, don't tell me that. I don't want to know this, because it's but it's important for that log aggregation system to be able to go that next level of, when I get something and I index it, save it, whatever, do I got to tell somebody by one method or another? With containers, what's inside that log message is going to be useful for somebody else to know down the line. So what they are and what they do, this actually was a note to me to replace this with something else. So that's doesn't say TBD like it was supposed to. The main thing, though, is that they get those log messages and they probably index them, if they can, do structured text, whatever it is they want to do, stick them in some database somewhere, and sit there and wait with anticipation for somebody to query on this useful piece of information. It's important, push and pull to the aggregation system, because, for example, one of the things I'll talk about with Docker is that with Docker events, you can't push them, or you have to push them separately. It's not like the engine itself will send them to Splunk. You got to find some other way to get them to it. I'll show an example of that. I'm going to pick up speed on this because I'm spending too much time jawboning with these things. Generally, is everything working fine? That's the number one question, I think, in log aggregation. Troubleshooting becomes necessary, but is everything working? Is everything all happy, hunky-dory? And there's a ton of different information types being sent to them, particularly in container environments, because we're not just talking about applications, we're talking about that whole stack of stuff that's happening as well. It's important for that UI to be easy to use. That's something that I've always found with Splunk. I tend to find that I can do stuff pretty quickly in the UI, and I've had some trouble with other stuff, but it's also what I tend to know, which what you know is always easier than what you don't know. So dashboards are important. I'm keen on this for one reason, and I'll mention it again later. I'll mention it now. Developers should never send code to test or code to production or whatever the process is unless right alongside that is a dashboard or a panel that says, here's how to monitor my service. The ops person should not have to sit down and say, I got me a sack of software, I'm going to stick it in there and stare at it for a while and see if I see something useful come from it. Instead, they should have something that goes with, conveys with the code that says how to monitor this whole piece of this whole service, because it benefits the developer. They don't get a call at 2 o'clock in the morning saying, hey, I'm getting a funny message I've never seen before, if their dashboard has a way to say read red or a gauge or panel or whatever it is that says you can glance at it and tell, is everything probably okay with this service? I'm particularly keen on that, and it's a hard thing to convince the value of because it only saves developers effort down the line. But that means they need to use the log aggregation system during development. And this is something else I'm particularly keen on, is that you shouldn't just be running an aggregation system specifically in production and not anywhere else. Because if you don't run it in development, your developers are never going to get used to it. They're never going to use it for their debugging, which is how it starts basically. They should be using their log messages that go to the aggregation system for their debugging, not sys.println.whatever it is or console.log or whatever it is. That's the worst way to debug something, so, or to figure out what's going on. Data management matters. With containers, you got all kinds of stuff that might be logged to it. You got to be careful about that. Easy way to do notifications. Let's keep going. Why they're necessary. That's another message to me to replace that. So key thing is one place where all this stuff is being sent to, so you don't got to reach out yourself to find all these nodes that are coming and going constantly. Lastly, historical records. Is something different happening now than happened yesterday? Is the seasonal traffic this season the same as last season? Are we getting requests at a rate we've never gotten from somewhere else? The aggregation system will help you do that. It'll also, if you're sending all this container data to it, are we running more containers today than we were yesterday for some reason? Are we pulling images today, but we weren't yesterday? I mean, that's an example of the kind of things that are useful to have sitting in aggregation. So historical records. Now you're going to see things. You're going to see like ELK. You're going to see FK. Fluent. I've been using Fluent off and on for a while, and it certainly is an evolutionary. I think that it's kind of useful, and I'll show it later in a little diagram. So open source type stuff. Other ones. Typical ones: Splunk, CloudWatch, Loggly, etc. Or you got your roles your own, and that's not unusual in enterprises. They've cobbled together a bunch of stuff over time. It's still an aggregation system. You still have to find ways to get data to it. And in a container environment, you have exactly the same problems with that. So some of the providers you're going to find for container environments are going to be Docker with Big D, the company. They have stuff. You can also find Swarm and UCP, open source type stuff. You can run your own, or you can run Docker Enterprise Edition, or whatever that thing's called. Red Hat's OpenShift, which is Kubernetes ++, for lack of a better way to describe it. Take Kubernetes and then look at what Red Hat and OpenShift specifically did, adding on top of it. They did quite a bit of work. They added a bunch of things to Kubernetes. Kubernetes is coarser. OpenShift added a bunch of things to it to make it a bit easier to use. So it depends on your definition, your leaning, et cetera, what relationship you have already. And got the Google Cloud. I mean, I've been using this for a couple of things, in fact, with what they're doing, and this gives you a chance to actually look more carefully at Kubernetes. You can run a Google Cloud container instance, SSH into it, and do some interesting Kubernetes stuff. Then you got ECS, which is a whole another world of containers. So places that logs are going to come from, things that you might want to collect information from. Log files themselves, meaning the Docker engine is logging stuff that might be useful to collect. It may be sending stuff to our syslog. You may be able to go to our syslog or have our syslog forward var log syslog or whatever to your environment. But that's another example of where you might find things that are being logged by containers or Docker environment that is useful. Got the engines, then you got applications. So with a fair amount of Docker logging, you're seeing application level logs, but the engine logs are, I think, as easily as valued. The application container logs, I mean, they're the things you've always dealt with. You may get them in a different place than you did in the past, but they're still the same container log. It's these other guys that I think can be a little more informative. Then lastly, you got the API itself. Potentially, whatever your orchestration environment is, has an API that your aggregation system, Splunk, can interrogate. It can use that REST interface, pull something from it, because there are some things you can't do in log files that are only available via the API, in fact, or the UI or the APIs. And I'll show an example of that in a bit. So, what might you want to collect? Stuff at the infrastructure, nodes coming and going. When you have a scaling event, it's not a bad idea to, I mean, maybe that's available in CloudWatch or CloudTrail or whatever, but it might be a good idea to have that kind of thing occur, be showing up in Splunk as well. The engine logs. That's going to vary depending on log level. What it logs is surprisingly good in info, for example. I've seen a number of things that are useful at debug level, but then it has a crap load of other stuff you don't want. You got to filter out. Engine events. I'll show some more about events in a bit. Who's doing what? Who's running containers? Is it happening by person? Is there something unusual happening? Cluster management, meaning when nodes come and go, and UCP is what I'm more familiar with. When UCP starts doing stuff on a new node, it's not a bad idea to be aware of this sitting out there. It's something new that's happening. Maybe. Lastly, is anything wrong? Is anything different now than before? And can that be traced back to a problem? What was done in the last 15 minutes, for example, is an example of some of the things that are worthwhile to be able to see. Go a little bit further. Remember that registry that I showed out there, the registry server? It's likely he's generating logs as well. He's going to have information that's likely completely different than the other stuff. It's also possible the registry is another container environment. Very likely is. In the case of UCP and something called DTR, Docker Trusted Registry, it is another container environment. So you got a Docker engine, containers doing stuff on it. What images are you running right now? What versions, what layers are inside those images? What versions of them? Do they match what they're supposed to? Who put them out there? When did a new version get introduced? Is anybody trying to authenticate with the registry and failing? You know, if so, to deal with that registry, you're probably going to have to log into it. Now, by default, you should be able to get a Docker hub if you're running Docker on your own machine. But again, if you're going to push stuff to it, you got to authenticate. Your own registry, authentication is going to matter. It's a good idea to be able to tell if somebody's trying to authenticate and can't. Image vulnerability scanning. This has shown up in more recently, I think, than the other stuff, and that is those layers of images that have been produced, they have files in them. Those files could be Ubuntu files, CentOS files, Alpine files, etc. Those files could be Perl. They could be who knows what. I mean, just a ton of them. When vulnerabilities are found, they say, hey, this version of Perl has a problem, and we're running this version of Perl in half of the containers in our system. Are you going to do something about it? How are you going to know it happens? Image vulnerability is how you do that. Now, interestingly enough, an aspect of image vulnerability with the DTR, again, what I'm familiar about is that you can see it in the UI. It is not logged. The vulnerability scan results are not available in the log. Instead, you have to either use the UI or use the API to get them, and that's a little bit more challenging. Somebody can sign images cryptographically that says, I am who I am, and I'm able to sign this image, and I'm able to store it somewhere. It's worthwhile to be aware if there's attempts by Notary, one way of doing this, that are failing. And lastly, again, container logs. So, most of the time, you're going to be integrating with an existing log aggregation system. That's what I found with Docker. I mean, invariably, customers never said, we got no log aggregation, so you can do whatever you want. Generally, as we have something in place already, it would be really nice if we could use that instead of adding something else entirely. Logging gateways are useful potentially at the node level for the kind of stuff you're going to send on. I'll show a picture that explains that a little better in a bit. Ways of getting it potentially are via rsyslog. That's something that we've done a fair amount with in terms of how you're going to get that log data from the host sent to Splunk, for example. rsyslog is a way to do that. It's easy to configure. It's got its own language or syntax for filtering some amount anyway. What's it going to cost to have this aggregation system sitting out there? Generally, It's easy to stick that thing in, log all kinds of stuff to it, and burn your license up in a hurry, and then go back to your financial CFO and say, we need more license. And that gets kind of expensive after a while. And it tends to not be dealt with well. And the effect often is, well, we'll stop using it in dev, for example. That was my experience previously, something that I saw. So that is always the worst case, is to cut back on something. If you can avoid that by filtering, it's particularly a good thing. So you already know this with Splunk. It's about as intelligent as you're going to get. What I said earlier, developers need to recognize the value of that aggregation system as early on in the service as they possibly can, their development, maintenance, et cetera. Because if they don't, they're not going to think about it, which now means that burden becomes technical debt pushed down the line to ops. You got ops technical debt in effect. So I'm a big believer. It should be sitting out there in all the environments, dev, test, prod, and whatever. I've always felt that way, but it's not always practical, but it is certainly a good thing. Developers need to recognize, make me a dashboard now, it helps somebody else later, which makes me look good. I mean, imagine how, if you can convince a developer, not only does your code work, but your monitoring dashboard works too. It makes them look good, basically. And that's not a bad thing to do, is stroke them some by saying, hey, great job on monitoring. Now, here's something we've observed. If your log aggregation system is running as containers in your container environment, and your container environment's having trouble, you can't trust that aggregation system anymore. So in other words, I'm cautious about something like aggregation running as containers in an environment I'm trying to monitor. Because if something's going wrong in that environment, networking, disk, whatever it is, it's possible that you're going to have trouble with the aggregation because of it. So ideally, separate machines, separate servers, whatever, however it is they're doing. Of course, that jacks up the cost. Now, something else that's important is that when you run containers, you can associate labels or tags with those containers that add a bit of extra metadata on top of that. That metadata can be included in your logging automatically. So every container that gets run has the project name on it, the whatever it is. I mean, just a range of things. That ends up in the log, that log gets sent on. So just be aware that when you're running something, you can attach, when you're running a container, you can attach metadata to it, and that will be available if you are forwarding that on to the aggregation. So how you're ingesting with Splunk is going to do it with 85.4 or 514 or 85.14 with syslog. You're going to do it with log forwarder. You're going to do it with UDP. I mean, all those things are things that are sitting out there. The container environment can facilitate all those, or you likely will use all of them, frankly, because there are some things in the container environment that you're going to want to forward as files, which now means you have to use a forwarder, or may have to use a forwarder. There are some things that are available in syslog, which means you're likely, or in the journal, for example, which means you're likely going to use syslog. So the container environments are going to generate the same sort of will have the same sort of interface outputs that you're likely already dealing with right now. Potentially sending to some sort of queuing system in between is a way to do that. The forwarder, the Splunk forwarder, is smart enough to do this queuing itself, but having it available externally is another thing to consider. Any questions, by the way? Yeah.
Fluentd, is that a gateway for writing to the logs or consuming the logs?
It's a gateway for forwarding the logs. So I'll show a picture in a bit. An experience that we had was that setting Fluent on a node. This was an OpenShift platform. Having Fluent on the node and having it receive syslog, and then having all the pods, in this case, sending to syslog, and then the Fluent configuration decided what was going to be forwarded to Splunk, what was going to be dropped on the floor, what was going to be enriched. So I'm calling it a logging gateway. It's not a consumer. It's a pass-through, a smart gateway, literally, in terms of deciding what's going to be sent on and what's not.
Okay.
Does that?
It's like a message router. It's like a message router.
Yeah, it's like a message router and enricher and drop on the floor, for whatever a good way to say that is. So because the container is going to generate a lot of log, having points to avoid those things being sent down to Splunk as early in the project as you can is a good thing.
I have a question.
Sure.
From developer's perspective, what do you mean by developer building greenfield, like using proper logging systems?
What I mean by that is,
using Docker's logging?
well, obviously, Docker's logging is at the application level, certainly.
Is there like some coding involved in terms of developers point of view? send logs to Splunk and that is using the app itself?
I don't think so.
On a microservice?
In the perfect world, the Docker engine is configured to forward to a log aggregator everything that the application logs are sending, or whatever it is you want to send to them. Those application log entries are ideally JSON, because I'm big on JSON, that are set with key value pairs that are easy for Splunk to consume. So what I think the point I'm trying to make is that if the log aggregation system is available in the development environment, the developer will tailor their logging to accommodate constructing panels and dashboards in Splunk to do queries. If it's not available, they're going to tend to do a lot of sys outs or whatever. I've already forgotten what it is in Java, but anyway.
Okay.
So the console log, whatever it is, they're going to tend to do bits and pieces all over the place that are just logging little things, as opposed to a structured log message at particular points that contains a lot of information, and that's what gets sent to the aggregation system where they're developing or creating their dashboard to monitor their service. So that's really what I mean by that. Okay. So now, something to be aware of. Here's lesson learned. This was with, this is true both in Docker and OpenShift. And that is, in some cases, when you start forwarding, you're going to lose some local abilities. So by that, what I mean is in the OpenShift UI, for example, you can go in, see a pod, see the tasks running in it, and see the logs from them, unless they're being forwarded to something else. So you still have them in the downstream area, but now you've lost that UI that might be useful or somebody's already familiar with. So we had to do a couple of things with one case of having a sidecar that would act as a syslog server, pick up the syslog from the container, and that sidecar would send it on to Splunk and log it to standard out. By doing that, it would still show up in the OpenShift logs UI. That may make no sense to you at all, but if you've used OpenShift, it's going to have, and for that matter, all container environments are going to have some way of looking at logs on this node for this container. But it's at that level as opposed to sort of the aggregate level. And doing forwarding from a container environment may break that, which may not be bad. It's just sometimes it's useful to drop right down to the UI that somebody is already familiar with. So just something to be aware of. Enriching, this guy right here, which you can't quite see because of the thing, says how to label containers. There's something I mentioned earlier about when you run a container, you can enrich it, you can add stuff to the metadata associated with that. That actually gets saved in there. And when you do Docker inspect, which will tell you more about the container or volume or network or whatever it is, that metadata will show up in there as well. That is an example of things that you can use downstream that can be very useful for knowing what was this, why did it get run. And this is the point I said earlier. If you're using the Splunk driver for Docker, I can't think of what it's called, but I guess it's called Splunk driver. If you're using that, the local logs ability likely stops working. Instead, you have to look into Splunk. So it's just something to be aware of, that when you turn on this, it may stop things that are at the intervening level you're familiar with already. So that earlier picture that I showed, where you got one guy, this is one host sitting here, the CLI, got the Docker engine, got the application container running. Each of those things may actually produce useful stuff that can go to the logging server. By that, what I mean is the engine is certainly producing logs. The application, I'm talking about engine level logs in this case. The application container is producing logs. Docker events is something else I'm going to talk about a bit more later, because you can learn a surprising amount of what's going on in Docker by looking at Docker events. Those as well may be useful to send to Splunk. Then you've got the registry server, which is where you're getting your images from, what's managing the images, what's storing them, etc. It as well likely needs to be sending on to the log aggregation system. Go up to the clustered environment, and now you've got, again, a manager node. You've got X number of worker nodes. All of them are just trying to go send stuff all over the place. This is where it starts to matter. How does Splunk know who it is that it's getting from? What does it know about this server already? Does it know nothing more than an IP address, which may be the way you want to do it? But it's just something to consider in terms of container environments, and clustering are going to create likely a lot of these guys, the worker nodes, all of whom are going to make connections to that logging server. Now, I'll talk a little bit about Fluent in a bit, where we'll see if this is not a good thing, there's other approaches to doing this. So In this case, consider your developers are doing it. They're connected to it. And you've got your clusters. They're doing it. All of these things are being sent off to Splunk. And how does it know what's going on? So it's not likely you've got, I doubt you'd have one Splunk server for development and production, for example, but this might be considered a test environment where all these things are happening. So Fluentd is what I mentioned earlier as things to consider in terms of a gateway. So think of it this way. Rather than having each one of these guys sending stuff onto Splunk and potentially doing filtering at that individual level, instead, consider whether or not it makes sense on your nodes to have a Fluent container running, or just Fluent installed on each node. That's consuming by our syslog, having everything on it, on that node being sent to it, and then the Fluent configuration is deciding what to send on. It depends on which is easier to manage and understand and et cetera. In the end, it's what you're most familiar with. But Fluent is really good as acting as this gateway, logging or gateway of forwarding stuff.
So before we go on, sorry.
Yeah.
Before we go on to the next piece, the Docker engine in this example logs, looks like it sends data to both an events
Okay,
functionality and Fluentd.
I drew a poor picture of that. Well, I drew a poor picture of that. This is not actually a piece of code. I'm just showing that the Docker engine emits events that don't go to a log file. So instead, and I'll show it in a bit what I really mean by this. You actually use the command Docker events, and it starts streaming events from the engine. Then I take those events, I filter them through JQ to get what I want, and send that to a file. And then I have the Splunk forwarder sending that file on to the engine. So this is what I'm really showing is that the engine emits events, and those events have to be. They don't get logged. I'm trying to show it doesn't get logged. Instead, it's a no stream of data. Anyway, I'm not. I'll show you an example of that in a bit.
Does Fluentd run as a container here?
It could be either. So we did it both ways with OpenShift. We ran it both installed on the node, which meant it had to be provisioned on the node. We also did it as a container on the node. It felt like it was better to run it installed than as a container. But I'm not a pro at Kubernetes or OpenShift anywhere near the level to say whether it makes a difference or not. It just, I know we tried it kind of both ways, and in the end, it seemed like running it installed worked better because it was baked into AMI at that point. Docker events. So if you look at Docker events, they will, by that what I mean is if you look at all the events that are possible, you'll see a ton of them. It is surprising how many different things can happen. I put a couple of links in the presentation. You can go to these and actually see some of what's being talked about. I have a little more information here. There, for example, the types of events, there's something like 7 of them, 7 super types. For each of those types, there are the specific events. So for example, for containers, when something happens with a container, the events associated with that are something attached to it, a commit, which say that container to an image. That's what that means. Copy it, create, destroy, detach, die, exec, blah, 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 blah. Each of these are steps that are happening in the life cycle of a container. Events really describe the state table associated with a container for this. Images, it's got its own series of events. Now, the reason I'm saying that is that you probably don't care about most of these, but some of them you just might care about. And I have a little more example of that in a bit. You might care on every time someone does a push. It's worthwhile to know who just pushed an image to the repository. That's not a bad event to keep track of, for example. Who deleted an image? Who tagged, who untagged? I mean, those are all things that are considered in the life cycle. Plugins, if you're using plugins, that's another way to add interfaces to a Docker engine. It's got its own series of events. Who just installed a plugin? The fact that it happened is probably important. It likely should happen infrequently, but disk volumes, I keep saying disk volumes, are really volumes, they're really space allocated to a container. Create, mount, destroy. All those things are things that may or may not matter to you, but it's worthwhile to know they exist because they may help you with troubleshooting. And whether or not you're logging them, they are available in the Docker stream, meaning you can go onto the host and do Docker events since 10 minutes, and it'll show you all the events that happened in the last 10 minutes, or it can show you specifically. So whether you're forwarding them or not, they are still available for some period of time, although I don't know what that period of time is now that I think about it. Networking related activities, reloading the Docker engine itself. All those are events. So here's an example of what I mean when I say events. if you actually type the words Docker events and hit return, it'll open a connection to the engine, and every time one of those activities happen, the engine will squirt out an event. That event will be in JSON. Actually, it'll be JSON here. I'm not sure what the regular form of it. It'll be in the form of JSON. It will be tons of them. A lot of the frequency of them will be health checks that are happening within your system. You probably don't care about that. So what I show right here is taking Docker events, setting it to JQ, JSON query or something like that, whatever JQ stands for, is a really popular useful thing. Send it to JQ, have it take these 5 types of things and drop them on the floor, because they happen a lot and I don't care about them. But every other event will get sent on. In this case, what I'm doing, I'm saying Docker events, send it to a Splunk events file, and I've got the forwarder tailing that file, sending that onto Splunk. So what I started with was Docker events to this, looked at all the stuff going into Splunk, then started picking individual things out, and that's where we came up with this these filter commands. And in fact, I had it in a cruder fashion. Eric figured out a better way to do the syntax on this. It's easy to see type stuff. But if you don't do this, they're not logged. These events are not being logged anywhere unless you explicitly are doing it this way. Some of the lessons learned that we've discovered. One, some of this is Splunk related. It's important at the start of the project, when you start using Splunk, on day one, start figuring out how to filter out what you don't want, because that's going into your license usage, and license usage will hurt you down the line. If you're logging a bunch of stuff you don't care about, get rid of it as early as you can, because it will be a pain in the butt later on. What are you doing? I mean, how are you keeping this stuff? Where are you keeping it? How are you going to roll it over? Are you sticking it in S3 or whatever it is? And I'm not nearly a Splunk expert, but long-term storage. There was a really good presentation made a few months ago here by somebody that was talking about long-term storage. It was really impressive to listen to them talk about long-term storage, not just storage, but re-indexing if you lose it. You may be replicating it. That storage, you lose that storage by whatever means, and you got to re-index it. Now you've got a problem in terms of monitoring environment. So anyway, it was a really good presentation months ago. We actually have, we have the video. Again, I come back to this. Make developers see the value of that log aggregation system during development. Don't have them treat it as, I don't care about that because I can do my sys out. And this is something that's always interesting, and this is hard to do. And I've tried to do this a couple times and never been successful. What's being logged now that wasn't logged before? It's like, and you can filter out timestamps, filter out all of other things, but the crux is this message new? That always matters to me in terms of troubleshooting. There's something new happening that wasn't before, and I may not know it's there unless I have a way of saying, show me something new. I experimented with something ages ago with another company where we were taking it and sending it to MySQL and doing exactly that, doing pattern comparisons to decide, show me everything new that got logged today that's never been logged before or something like that. It was interesting activity. So a bit more. Those Docker events are a very good example. There's a ton of events that are happening. Rather than saying I'm only interested in capturing these, it's better, I think, to filter out what you don't want, because you're going to miss stuff you may be interested in that you don't know is happening, because there's just a lot of events. So this filtering out rather than filtering in, I think, is a good approach, because you might miss events, what I just said. This is interesting. Occasional warning. So in a container environment, you see some weird messages, and I might have one. Let's see. Like this. This message started showing up a week or so ago, and I'm still not sure what it means, and I can't find it. I can see it in the source, actually. I can tell why it's doing this. I just don't know what it means. Do I care? Odd messages that may pop out in a container environment. In this case, found a leaked image layer. I go and look. I can't find that layer. I looked around all over the place on the node. That image is not there. I'm telling you, it's not there. Eric doesn't believe me. It is not there. So I don't know if this just means it's got some metadata that isn't really valuable. But if we're in a big installation and we're pushing and pulling thousands of images all the time, and this actually was leaking something, is it accumulating space that eventually is going to wait till 2 o'clock in the morning on Saturday to fill up your disk and bring everything down, and then you get a phone call saying something's busted? So those are the slides that I had. What I was going to show now was the UCP that I got running, a little bit of Splunk that I got running. But again, back to questions, because I can talk a lot, and you may be getting tired of hearing it. Yep.
So can you talk a little bit about the interaction with developers and your log system? Specifically talking about, okay, in development, there are some things that are legal, debug logs, trace logs, really detailed stuff that developers need to do their job, but are not legal in production.
In a PCI, right? Absolutely. Oh, sure, absolutely.
Well, PCI, but I was thinking more along the lines of log capacity, disk retention, and killing your log aggregator.
Oh, yeah, true.
Debug gets turned on in production, and the overwhelming volume.
I expect that to be the case. So that comes back to in a development environment, you probably are not running it in the same way the aggregator's point. The same way, you're most likely running it on a less retention type thing. For one thing, I wouldn't expect it to be retaining for long periods of time, just to save on space. And it also facilitates or encourages developers to log more at the debug level than you would in production. Obviously, you most likely would not have debug level logging turned on in production unless it was specific cases. So back to your question, I think that developers can have it set to whatever level they want at their own instance level, and the aggregator is trashing it as it needs to in development. Does that answer your question?
Well, sort of. I guess what I'm trying to get at, let me see if I can ask it a different way. So developers like to have debug in development, test, and integration environments because that's what they need to do to get their job done. In production, you don't want developers saying, well, I need debug because that's the only way I can get information.
And that is the case right there. If they are using the aggregation system, ideally they would not be logging at the debug level. Individual, the debug level would literally be little boogers all over the place doing all sorts of little things.
Right.
Instead, it makes way more sense to do it at the info level that has a collection of useful pieces of information at a choke point in the process. Meaning they probably don't need to see the inputs and outputs to every method that they're calling. Instead, it tends to be more of a super level where they have a single message. That one message is not consuming a whole lot, but it's still informative at the info level. So if they are using the aggregation system and they get used to coming up with their own dashboards, their dashboards won't need to have that really they probably won't need to have the really granular level unless they want.
So when you're talking about developers that come out with their own dashboards or panels as part of the code deployment, does it sound like a good rule would be that what goes into the dashboard cannot be things that only exist in debug and trace? They have to be at info or higher?
True. Well, that's interesting. Actually, that's an interesting observation. I thought about it at that. They had to be, I would say it's part of the criteria of accepting software. The panel you should be able, QA potentially should be able to look at that panel and say, this is logging way too much, it's going to be bad. Or ops gets sign off on it, basically. Meaning, ops should be able to look at a dashboard before something goes in production and say, this contains the kind of stuff that we want, or you're logging way too much. It's a way to potentially add a filtering criteria to acceptance.
Can you talk about the sidecar patterns?
Yeah, that's what I was saying earlier. What we did with the sidecar with OpenShift was we wanted the OpenShift UI to continue to, the log tab in it, to continue to show the output from the container. And when we turned on log forwarding, it stopped doing that, which now meant that you lost the capability in OpenShift, basically. So what we did was we had this was for HA proxy. Yeah, now I remember specifically. It was HA proxy. An HA proxy container, you go into configuration and say, forward to this syslog server, and we had that be Splunk. Worked perfectly, but the UI that should show the log for that HA proxy stopped in the pod UI, or the container UI, whatever it's called. So we did a Python sidecar that was a really simple one where it ran in the same pod, presented a syslog interface. It was a simple Python script. Then we told HA proxy forward to Python, to the syslog, which was that Python. It squirted to Splunk and logged to standard output. So it acted just like a T in Unix, actually, exactly like a T. And then the log tab in OpenShift started working again. It worked really well. We fiddled around for a while before we figured out the right way to do it, but it ended up being not 20 lines of Python to do it.
Well, so it should be important to state, like that message up there is coming from the Docker data itself.
Yep.
That's what you traditionally think of as like syslog.
Yep.
In Docker, when we're talking about logs, Docker is basically receiving out the standard error from the process, and that is basically what it considers the log of the application, and then it has the ability to forward that data out. But if you need more sophisticated logs or tagged logs, I think you might need to have a separate log process.
True. I think that's true. It's analogous to the sidecar, really. I mean, what we did. So in a DE and or UCP environment, there aren't sidecars. That's one of the other things about Kubernetes that's interesting, is that sidecar concept is interesting. So again, when you start talking about container environments, there's a variation in them. Some have advantages over others, and you potentially will be exposed to all of them, all these variations that'll affect the way you do stuff. But Kubernetes sidecars, I thought were kind of cool. It was funny, just as a aside. It was I know what it was. We ran syslog as another container in the pod. And again, if you're not into OpenShift, this for Kubernetes, it's going to make no sense to you at all. But in the pod, which is a service, a collection of container resources, so we ran another container that was syslog. And what it did was it would attach to JBoss, reconfigure it, and then exit. Except with pods, the restart policy for the pod was if a container exits, start again. It would just continually start flapping this little thing that we had to do configuration stuff. It was a JBoss thing. But anyway, it's an interesting little exercise. That's what caused us to have to do the sidecar with syslog. Any other questions? I talk a lot, I know, so I don't hesitate to ask. Let me show you really quickly. Let's flip to this guy. Let's take a look here. Let's see. I don't know what's this guy been doing for last season. Probably nothing at all. Let's go 4 hours. Yeah, it's logging stuff. So I have some simple dashboards that are main monitoring. I mean, basically they're just different approaches. I mean, it's all Splunk stuff you're going to be familiar with in terms of what's coming from syslog. Not a whole lot's been happening. These are examples of the kind of things you're going to see. Is this good or bad? I don't know. Container environments may be a little more confusing, as to what stuff means, particularly in terms of the orchestration mechanism, in this case, UCP. And I had another little guy, which was monitoring. What does it mean? Yeah, authentications, pulls. This goes back to what I was saying earlier about just a general awareness of what's going on. Who last did a Docker login with DTR, for example, the registry or repository, for example? Who did it? What account was used? Image pulls. I meant to put up a graphic and I forgot to do it, and I have to fiddle around before I get visualizations to work. But every time that a pull occurs from the registry to something else, it's worthwhile to be aware that it's pulling an image from somewhere else. Meaning, did the frequency of that go from 0 to 50 a day? It may mean that images are being versioned, you're not aware of it. In other words, it just gives you more awareness into the, for lack of a better term, the binaries that are being run, which is what image layers are. UCP, yeah, I'm not going to see it very well, are you? So picture in your mind, well, I guess you can slide it around. So UCP, which is the clustering mechanism for that I'm mostly familiar with. We'll see it. I got a 3-node or 2-node cluster, or 3-node cluster, that's right. I got one manager, this guy right here. I got 2 workers. One of those workers is running the registry or DTR. So you're going to see these kind of things in terms of when you go into a container environment. UIs are going to be different, the way things appear and so on. They're probably going to have their own stats related or metrics related stuff. Something else you'll hear the term Prometheus is a really popular metrics thing for container environments or Docker environments. Prometheus is pretty slick, actually. It's at the metric level. It's not really it's not logging type stuff, but it's still an awareness type activity of what's going on in your system. Let's say images. Here are all the images that have been pulled from me doing the stuff I've been doing the last few days. Hello world, oddly enough. all the UCP and DTR related images or containers that are being run. That's what these guys are right here. Let's go one other thing. I've been mentioning DTR, Docker Trusted Registry. It's just a repository basically. So here's 3 images that I intentionally pulled. I was talking about image scanning earlier. You may not hear me. I was talking about image scanning earlier, where each of those layers of images contain files, programs, for lack of a better term, or data files that may have vulnerabilities in them, may be malicious or whatever. It just bugs. One of those things gets aged or it got a problem that gets found. Let's go to one of my little repositories I mess around with. Look at that. So what you're looking at right now are image scanning results. So with the license that we have running on this thing, it will scan those images all by itself in the background. It pulls a CVE database from somewhere else, scans all its image layers that has vulnerabilities, and then notes them. It only notes them in the UI and via the API. It does not log any of this. This is what I was saying earlier about a pull type model where Splunk uses its REST interface whatever that thing out of Splunk based is, to pull registry scan results data. So anyway, you could do that. This is what it looks like if you look at the details of it. Here are the layers of a container. It's hard to see this full screen. There we go. So it found vulnerabilities, known vulnerabilities, in these 3 guys right here. Now that sounds so what? It can't be that big a deal. Go back and talk to those Windows guys that didn't update their servers that had the ransomware hit them upside the head a while back and say, had you updated, this might not have happened. So after the fact, it's nice to be able to look at this and say, we have no vulnerabilities. At least it's some amount of protection. But so anyway, image scanning in a container environment will matter to you. When you see major and critical, it certainly gets your mind. So Splunk can use its REST pattern to retrieve this same data and log it that way. Otherwise, it's only available via the UI. And the reason I complain about that is that let's say I had 100 images sitting inside here and 3 of them had vulnerabilities. How do you find them? One by one, go down the thing. So it's a little more effort to do that via the UI.
It doesn't scale very well. It won't scale very well to hundreds of thousands of
images. Oh, absolutely, sure. I mean, yeah. This is an example of you'd absolutely use the API. I forget where is it? Where's somewhere in here the actual vulnerability is. Oh, there we go. Ubuntu's bash has it. Now, something to recognize, and this is something that we teach in our classes that's useful. When you see, and if you've done docker.onc from Ubuntu, it doesn't mean you're running Ubuntu in the image. You're not getting an Ubuntu operating system. You're getting the files in the base image of your Ubuntu, and you're pulling some number of those files into your image. So, again, that's a Docker discussion. There's a whole lot of depth in Docker that I can go into, but you probably would get tired of it. What else? Let's see. I don't know. That's probably about it. Right? Yeah. I think good pitch worked okay for this, maybe. Anyway, you can find the presentation there. I put it in the link, whatever. Any other questions or comments? I know this was wordy and I bounced all over the place like I typically do. It's a big subject. I mean, it's a lot of containers is not a small thing. And not only is it not small, it's all right. Any other questions? If not, we'll switch back to the camera view.
Inception view.
Yeah, the inception view. Let's see if I can do that. Let's get this guy. Hopefully this stream worked okay. Let's switch back to. Oh, there we go. There, our camera's live.
Yeah, the stream kept up the entire time.
Oh, good.
All right. Well, thank you very much, Doug.
There you are.
Just circling back, like I said, anyone that wants to do a talk or have ideas about talks, definitely come and talk to us. If people are interested in doing the Trellis layout competition, the best place to probably start that conversation is the DC Slack channel. So if you want to start asking people if they want to get involved in the Trellis competition and get together, I'd suggest probably doing it there because that's where most people probably are.
Is everyone aware of the Slack channel?
Yeah, so everyone totally ignorant of the Slack channel, know about the Slack channel, don't know about the Slack channel. I know you can sign up.
I don't know.
So Splunk has basically started a Slack server for the community. So you can go onto the, and now there wasn't a site on the Splunk website, but now there is a place on the Splunk website where you can just go and sign up and say, I want to get in the Slack channel. And give it about 24 hours, you'll get an invite. And that's it. There's a regional channel, city channels, so there's a DC channel, the North Virginia channel. North Virginia channel is mostly dead, pretty much more the active one. So, but most people here are probably there. Yeah, so anyone that wants to coordinate anything for Charles Down competition, that's probably the best place to do it. Other than that, thank you all for coming. Please eat more pizza, drink more beer. Pizza, beer, disappear, whatever. And keep up to date on the next meetup. We'll probably be changing locations, but that following the meetup sites is definitely the best place to confirm that. So that's all. Thank you very much for coming. Thank you for Gripsis for hosting us.
Yep,
and
thank you.
Have a good day.